Hello and welcome back to Joe's Math Tools. In our session today, we will be calculating the HCF using the division ladder. And in this session, we're going to be using 3 separate division ladders. So if you want to see how that's done, let's get started. So in our example today, we will be calculating the HCF of 45, 27, and 54 using the division ladder. And in this session, we're going to be using a different division ladder for each of our numbers. So that's our 45, 27, and 54. And what I'm going to be doing first is we're going to factorize all of these numbers first, and then we'll go through the steps as to how to calculate your highest common factor. So we're going to begin as always by listing out our prime numbers under 20. So these numbers are going to be our reference point as we work through each of these division ladders. So let's begin. So our first prime number is going to be 2 and 3, 5, 7, 11, 13, 17, and 19. So these are the numbers that we're mainly going to use as we work through our division ladder. So let's begin by first using our prime numbers to factorize our 45. And in looking at 45, one prime number I know that I can use is 5. So 5 will divide into 45 9 times. So we now need a prime number that we can divide into 9, which is going to be 3. So 3 divides into 9 3 times. And now we need a prime number for 3. And again, we're going to use our 3. So 3 divides into 3 once. So now that we have finished with our number 45, let's look at the number 27. So we need a prime number that we can divide 27 by, and the only prime number that we can use is 3. Since we know that 27 is in the 3 time table, naturally we can use 3. So 3 divides into 27 9 times. So a prime number we can divide 9 by is 3. 3 divides into 9 3 times. Our prime number that we can use for 3 is 3. And 3 divides into 3 once. Okay, so now let's look at 54. And the prime number that we can divide 54 by is 3. And if you remember your divisibility rules, in cases like these, you can sum the numbers. So we know that 5 plus 4 is 9. And any number that has a sum of 9 is divisible by 3. So that's just a little tip on your divisibility rule that can help you to identify numbers as well, and identifying what they can or cannot be divided by. Or you could have also used 2, knowing that 54 is an even number. Naturally, every even number can be divided by 2. So it's just those little tips that you need to review that can help you with working with your larger numbers and identifying numbers that they are divisible by. Okay, so let's divide our 3 into 54, and this will be 18. So a prime number that we can divide 18 by, I'm also going to use 3 again. So 3 divides into 18 6 times. A prime number that we can divide 6 by, we'll use 3 again. 3 divides into 6 twice. Prime number that we can use for 2 is going to be 2. So 2 divides into 2 once. Okay, so now that we have prime factorized all of our numbers, we're now going to write their prime factors out or express them as a product of their prime factors. So let's begin with 45. So my prime factors for 45 is 5, 3, and 3. And remember that if a number is repeated 3 or 4 times, you will write that number 3 or 4 times, because it's important to make sure that these numbers equal back to the number that we are expressing or has been expressed in its expanded form. So 27, we have 3 3's. So 27 will equal to 3 times 3 times 3. And in 54, we have 3 3's and 1 2. So 2 times 3 times 3 times 3. Okay, so now this step is where we begin our calculation. And in calculating your HCF, we're going to first begin by grouping our numbers. And in grouping your numbers, you're going to be looking at each of these numbers and their prime factors. So with 45, 27, and 54, what I'm looking for now is one number that is common to all three of their factors. And in looking at these numbers, I can see that 45 has a 3, 45, 27 also has a 3, and 54 has a 3. And since each of them has a 3, I'm now going to circle or group this set of 3's together. So that will be my first grouping of numbers. And now we're going to look at these numbers again, and as you can tell, 45 has another 3, 27 also has another 3, and 54 has another 3. So now I'm going to also group this second set of 3's together as well. And I'm using different ink because in the next step I want you to also see how important it is when you group these numbers, how they should also be used. Okay, so now let's get to the part with our HCF where we will begin multiplying. So my HCF will equal to, and in our grouping we're going to be using one number from each of these groups. So in my first set of 3's, I will be using 1 3. In my second set of 3's, I will again be using only 1 3. And since I do not have any other pairs, I'm going to multiply these numbers together. So my HCF will be 3 times 3, which is equal to 9. Okay, so that will be my HCF of my 27, 45, and my 54. Okay, so I really hope that this video was helpful to you. I hope that the steps was very easy. Remember, start off by listing your prime numbers first, or listing as much as you can remember, even if you don't remember all. Then you're going to prime factorize each of these numbers separately on a different division ladder. After you've done prime factorizing these numbers, express them as a product of their prime factors in expanded form, and then group the numbers that are the number that is common in each of them. Remember, not separately. It has to be a number that appears in each of their prime factors. And then once you've grouped those numbers, if it's more than one, multiply them together. One, then that one number you group is your highest common factor. But make sure that you get some practice in, develop your skills, and we'll be right here in the next video on Jules Math Tools, where we make math easy.